So I just have to put the values here, and then it gives me whatsoever figure.
Yes, it's okay. You may use this approach. And also, I want you to add defined values inside your function. Please read information about Nargin. Yes, you may search. Could you print in search in the right search documentation? Nargin and
Nargin.
yes, and open help.
That's number of arguments.
Yes,
Number of input arguments.
yes, a new function. And I just recommend you to add this if sentence in the beginning of your function, because you may, using this, you may run your function without input arguments. So default mode like this. In the beginning, it was if nargin is equal to 0, then A is equal to something, B is equal to something, and so on, so on. And could you please tell me what is Z variable here? I see in output arguments X, Y, and Z. What
okay,
is
the Z is the linear regression that has the error. Y is just the linear regression itself. So if you see it, Y here is the
I see line.
Yes, while Z is with the error.
Okay. Okay. Good. So great. Thank you. Thank you.
All right.
You may continue working on this task. So add nargin, and also go to calculations of coefficients. Yes, it will be also function which take as input x and y values, two arrays, calculate coefficients, and returns b0 and b1.
So you said?
You need to add nargin to this existing functions and create new function for calculations of coefficients b0 and b1. Yes.
Okay.
As input variables will be x and y, so two variables, predictor and response. And as the result of the function, you will have b0 and b1. And you may check your calculations when you compare coefficients for your test set, because you choose some A, some B, yes, for your linear relationship. You after that, you calculate A and B using the regression model, and you will see they are quite close to each other. It means that your calculation correct.
That's a lot to process in.
Okay, just start to calculate B0 and B1. That's all.
Okay, I think I should start with B0 and B1 first.
Okay, so anyone else?
It's actually the same as I showed you in the previous session. Nothing has changed. I remember we discussed that I was wondering how to calculate B0 and B1 if I don't have the predicted value, because we have to compare them and find the difference. But then you told me I just have to, like, from the set I have to calculate a new y, right?
Yes, you calculate y as a linear relationship b0 plus b1 multiplied by x plus some error. It will be your y. So it's like a test variable. And you could you show your screen, because I don't see your screen, just to be sure that we are talking about one thing.
Just give me 1 second, please, because I'm using two different.
Okay.
So yeah, this one, I guess. Yeah, so this is the quadratic.
You need to add output arguments in square brackets. So it will be
X and Y, yeah.
Y, yes.
I remember that.
And also, please, guys, don't plot plots inside the function, because your function should only generate X and Y without any plots. And if you need to plot something, use it out of this function in your script, in your main program, because you need to divide your code in some blocks. So you have blocks. It means that you may use all these blocks independently in your future projects. So these functions only generate X and Y. And also, I strongly recommend you to add comments about your function in the beginning, which explain what this function do, because after 2 weeks you forgot about it. And when you look to the description of a function, if you see some basic information that this function creates two variables, X and Y, where Y depends on X by linear mode, yes. So A, B, and C, it's coefficients and number of elements in our arrays. So it really helps you in future. I recommend you to use comments. And also, when you're working in comments, when you need to share your code, yes, it's really important to create code which will be understandable for someone else, not only for you. Yes, it's like a clear code. It's a really good skill. So just also I recommend you. And here, here I also see a variable YQ on the line.
Yeah, because actually I
you plotted this here.
I wrote, yeah. I plotted it, so
you may.
Yeah, I'll just. Yeah, I'll use them. I'll like modify this function and I'll use them outside.
You may also return 3 variables as Benedict. It will be Y like a line, and Y plus error. It will be I don't know, Y2.
YQ.
Yes, so you may return 3 variables. Yes, YQ.
Okay, thank you very much.
You're welcome. So you may also finish this part and continue working with coefficients.
Can I go next?
Okay, Dimitris, could you show?
1 second. Okay, can you see it?
Yes, I can.
Okay, so this is my linear function with that. Okay, is it good? Is it okay?
Yes, it's okay. 1 moment, I will check it one more time.
Yeah, sure.
Maxwell, yes.
Okay, and this is my plotting. Like we did it in the previous session. I learned a lot of things doing it on my own. Like it matters how you write things, in which order. I didn't know it. Okay, so starts from here, function call, the results are here. And yeah, it was quite helpful for the quadratic section. Should I proceed?
Yeah, you may show. I think that it will be the same actually.
Okay, yeah. So also this is, come on.
1 moment.
Yeah, that's my, it's quite dense, but
I don't see figures, unfortunately, because I think that you share not screen, but program. And
oh, yeah, sorry. Let me do it again.
Okay.
Okay. Can you see my screen now?
Yes, I can.
Okay, so that's
Mm-hmm.
it's quite dense. If you want me, I can make it less dense. So
No,
whatever.
it's okay.
Okay, it's fine. So that's my quadratic function. It's without nodes. I don't know why. My coefficients are A, B, and C, and is you know. Oh well, you know what this is anyway.
Yes.
So, and that's my test number 2 for the quadratic. But I still didn't get the thing about the what you pointed out about the A, B, and C.
Nargin, you mean?
Yeah. Nargin.
But it's really good when you have some additional arguments at the end of the inputs, and for example, you don't want to declare every time you plot it. I don't know. You just standardize number of array lengths of the array, so it will be your last input argument, and yes, and you may define inside your function that if Nargin less than 4, it means that n is equal to 100, for example. Yes, and it's like some feature that you may use in your code. It's really
okay. So wait, right now it looks like that, which is good, right?
Yes, it's enough. You may add a little bit more variance in your noise. And I see that you have really high values of your response here. Yes.
Yeah.
You may choose maybe smaller step or smaller coefficients in order to perform not really just less values of your arrays. Yes.
So if I switch it to, let's say, 500, no, it's even worse.
But it's y is less than it was before, so it's better. And also, I see that in your comment window you have some output. Yes, some you forgot semicolon somewhere. Just you need to find this the line because this it makes your code slower. When you print output in your comment window, it means that you take some time to this plotting. Yes, it will be. Okay, it's enough. Yes, great.
Okay. So what's it? How do I use Nargin again? Like, I don't get it.
Okay, you need to add if state in the beginning of the function. In the beginning, yes, if Nargin is equal to 0, enter. A is equal to 5, I don't know, 2, choose what do you want. B is equal to something, C is equal to something, N is equal to something. It's like this. And don't forget semicolon in the end of the line.
Okay.
And don't forget and.
Oh yeah, of course.
And you may run this function without input arguments. You have an error because you need to use double
equal. Yeah.
Not here.
Nargin.
Yes, in Nargin state.
Okay, 1 second.
Here. Yeah. Yes. You may run this argument without. You may run this function without arguments with defined values. And also, I see semicolon after if line, so you don't need to. Yes, you may delete this semicolon.
Yeah, and it's a statement. Yeah, sorry.
Save this function. Save it. Save. Don't run.
I did.
Okay, and go to test 2. And don't run it now. Delete ABCN inputs. Just delete and
Okay.
yes, and you may call this no. You have ABC in the line 6. Delete input arguments. Yes, and try to comment line number 10. Comment line number 10 because you don't have ABC now.
Comment. Oh yeah. Okay. No wait. Sorry.
Control R. Control R. It will be also comment line.
Thank you.
And run the code. So we see that there is really unclear dependence. Let's go to function again and select n greater than you have now, because maybe you have small amount of data to see if it's dependent. Oh, maybe yes. Let's run this too again. So it's better, I guess.
So what I was saying is, you see that every single time he has to change a value, he has to go to the function and then change it and save it. And so that's what I was trying to prevent. We want to be able to change it directly from the function itself.
Yes, we may, but it's good if you have some default mode. You just select one time, you waste your time to select values for your input arguments, and after that you may call it without inputs. Actually, I want you to practice this approach with Nargins. It's not maybe it's not very good for this current case, but in some future it's like a skill. I want you to learn how to define some values inside the function if you don't have several inputs. In some cases it's really useful.
Now what Nargin does is, instead of declaring the coefficients here on my script, I declare them in the function.
Yes. You may use.
Okay, that's very simple.
Sorry, for the next, sorry, the next, what do I call it now? The next task we're meant to do, implementing the function, we're meant to create a new function.
Which function? New.
It says implement the function for calculating coefficients B0 and B1 using the list.
Yes, it will be the third function actually.
Okay, so we're meant to create a function that calculates these coefficients.
You take equation, yes, for B0 and B1, and just do it inside the function. Maybe it's not functions, but one function. I have maybe an error here in description. So you need to create a function, one function, which implement calculations of B0 and B1.
So we have
to create new function, yes. So thank you, Dimitris.
No, thank you.
What
sorry,
about
one more question. Can you please repeat how to continue our what we're doing now, please?
The next step is to create function which calculates B0 and B1 coefficients in accordance with linear regression model, and you will have function which I will print to the chat. So it will be function which returns B0, B1. Yes. And as input, it takes X and Y. Yes.
Okay, thank you.
So create new function, and oh, I forgot to upload lecture material. One moment.
I've seen this function before. CalCoef. I think I've seen it before, but I don't know where I saw it. I think it was in the lab work.
Maybe not in lab. I think that not in lab work actually.
I know I've seen CalCoef. I don't know where I've seen it, but was it here?
So I'm uploading lecture material. So we're waiting a little bit. I need to upload this file to our classroom. One moment.
Sorry, I have a question.
Mm-hmm.
If I want to implement a function in another function, like if I want to use this function in another function, is there some specific rules for that, or I can just save both functions in the file and use them?
You may save several. You want to declare several functions inside one file, yes?
No, I wanted to use
call.
to call a function in another function.
It's okay. It's okay. It's normal situation because you have some chain of functions in big project actually, but MATLAB should know what the function, where the function exists actually, and I strongly recommend you to collect all functions inside your working folder working folder, and also maybe you know that there are some paths to
sure. I need to select the path I am in. The functions are in.
Yes.
So it's the only rule that they should be in the same path. They should be in the same folder.
Not in the folder, but in MATLAB path actually. You may add actually in a big project you have a lot of folders. You just organize your functions by using some, I don't know, rule that this function for digital signal processing, this folder were functions for digital signal processing, this folder for functions for peak detection, I don't know, and something like this. You just organize all your code to several folders, and you add all these folders in your MATLAB path. You may click right button click to this folder, and to the file, you will see add to MATLAB path or delete remove from the path. And when you add this folder to your MATLAB environment, it will see that you have these functions inside the MATLAB.
Perfect. Thank you very much.
Maybe when I will connect to our class next time, I hope that I will have my laptop with MATLAB. I will show you some tricks how to organize MATLAB in your computer, MATLAB folders and something like this, because there are some funny tips. Okay, I'm publish my lecture. So you may find lecture 1 in our Google Classroom in the part where materials and reading. So lecture 1. And in our and you may take all necessary equations for B0 and B1 from this lecture. Okay.
I'm sorry, since we have this function you sent us, calc coefficients, do we need to use the equations for B1 and B0?
You need to implement these equation inside the function. So you need to construct a function that calculates B0 and B1. Of course, you have your defined.
We should name the function calc coefficients, or is it a function that already exists in MATLAB?
No, it does not exist.
Ah,
no.
okay.
It's like how to define, I mean, how I want you to call this function. So you pass your x and y and returns B0 and B1.
It's like
B1.
what data say. I understand. Thank you.
And it will be in the, we will declare this function inside the linear function, right?
Not inside. It will be additional file on its separate.
Okay.
There are. You see that we may calculate B0 and B1 for any array. For it doesn't matter x and y. It's like our variables. It doesn't matter if we generated them by our own using linear methods, your linear generation or quadratic generation, or it's some observables. It can be experimental data sets. It's only vectors, 2 vectors, x and y. It doesn't matter nature of these vectors. So you will have the third function, yes, which returns B0 and B1. And after that, you may calculate your prediction, your linear regression, and add it to your script.
Okay, thank you.
Okay, Harold, how are you?
Okay.
What are you doing today? Do you have some problems, questions?
Okay. You can see my screen.
You may show it. Not now.
Okay. Now, yes. Okay,
yes.
This is the linear equation. This one, and this is the quadratic. Yeah. When I'm trying to do this with Nargin, I make a run and this appears, but I check all semicolons and there are nothing.
You see that in line number 10, you don't have semicolon in the end. So,
okay. Okay.
Yes.
Yes. And okay, we have to make a function with this. Yeah?
Yes, exactly. Yes. So
this function will give us the coefficient of.
I'm sorry, the files you just sent us now. Where is it, please? Can't see it. Can you hear me?
Yes, we can.
I see the files you just uploaded right now.
File uploaded.
You say I can't see them. Where are they?
In our materials, we have block materials and readings in reading, and here we have file lecture 1. I'm sharing my screen. You may see also it.
No, you said you uploaded the file for us for the
yes in our classroom.
In the classroom, yeah. So I'm trying to locate it. I don't think I can see it.
Oh. You have some news in our classroom, and last news it's that I've added new material, lecture 1. You may click to this new news and go to this. I'm trying to send you a link in our chat, but I don't know exactly if it works or not.
You said I should go to news. Can I see any news here? I only see I see stream, classwork, and people. I can't see news.
Do you see some tabs?
Some tabs? I'm in the Google Classroom, not in MATLAB.
Yes, in Google Classroom.
Okay, yes, I see to do and methods of computer processing. Archived classes, settings.
Go to method of computer processing.
Yes, I'm there.
What do you see now? Could you share your screen, actually?
Okay. I think I should do that.
Harold, one moment. We will return to your questions also.
So yeah, this is where I am.
Yes, you see, go to classwork, materials and reading, lecture 1.
Okay, this.
Yes, this one.
Okay.
So,
is this what we want to use?
Yes, B0 and B1. Previous slide with equations. Not this one. B0. B0 is equal to mean value of y minus B1 multiplied by x mean x. To calculate mean value of the variable, you need to use function mean in MATLAB.
Yes.
From the first lab work.
Okay. Then what this will have to what do you call it? Do this in MATLAB too?
Yes. You need to calculate it in MATLAB.
How do I do
MATLAB, because MATLAB is a practical tool to calculate some mathematical things. So this is exactly what we may perform in MATLAB. So it's normal. Just analyze this equation and repeat it in MATLAB. Okay, Harold, how are you?
I think I know what to do. All right.
Okay, I am still here.
Great. Could you share it one more time and repeat your question about coefficients?
I don't know. I'm watching the presentation, and I think that I understand. We have to find B0 and B1 with these equations. Yeah.
Okay. Yes, exactly. And after that, you may compare the results of calculations and your predefined values, because in your model, you know B0 and B1 actually, yes, because you've defined it before, and you will have close results for your linear data set. Of course, when you will calculate B0 and B1 for your quadratic data set, you will obtain something, but you can't compare because your dependence between prediction and target non-linear. But when you will analyze residuals, you will see a pattern in the residuals, and you make a conclusion that this model is not suitable for the second data set. So it's only to show you that the first data set has linear relationship, and we will fit our model on this data and we will have good results. But for the second data set, we will have bad residuals and make a conclusion that the second data set is not suitable for analysis using with linear regression. Okay, thank you.
And can I ask you something about the lab?
Yes, of course.
Okay. I didn't know that we have like a function for coefficient correlation. So
the same
yes.
name, but it will be yes.
So what I do was I create a new one, a function with give me the median, the mean. Also calculate the standard deviation and correlation coefficient.
Oh.
But actually, I think that it's not correct, because if I run this, the coefficient are different. The coefficient correlation. So I don't know. Maybe something is right, is wrong with this function.
Could you return to your lab one? And also, I see that you are using a system name for the function mean. You redefine
this
mean function,
yes.
Because there are MATLAB function mean, which returns mean value of the data sets, and mean. And I think that also you see that mean 1 and mean 2, it's actually mean values of your arrays.
Yes.
T value is equal. Could you return to mean function one more time? And you calculate here some correlation coefficient, yes?
Yes.
I think that you have problems with your function, actually. We need to check the code, but for what? So just use standard MATLAB function mean to calculate average value of your array, and standard correlation coefficient function. And actually, you see that there are MATLAB function.
Yes.
Yes. No, but it's not calc_kf, but core_kf. Yes, it's close to our name, so maybe close. Okay, Harold, thank you. So continue working with B0 and B1. What about others?
Hi, can you hear me?
Yes, I can.
Okay. I can share my screen. Can I?
Yes, it will be great.
Okay. Okay. Here, the last lecture. I can run it.
Yes, let's look.
You can see it, right?
Yes, we can, but we don't see figures.
Ah, okay.
We see only code.
Okay.
Could you restart sharing because?
So I have a question.
Okay.
Hassan, one moment. We will return to your question a bit later.
This is the
quadratic.
And okay, and this is the linear.
Yes, perfect. Okay, that's correct.
Now I'm working on. Okay. On the finding the coefficients. Okay. Here the function.
Oh, great.
And here must be like this, or should I change?
Yeah. You see that in the first step you need to design to generate x and y. And after that, you need to calculate coefficients using these variables.
Not calling the function of linear.
You firstly call linear dataset function. Secondly, call calcaf function, because you need to define variables before you use them. In this code, you see that in the third line, you use x and y variables, but you need to define them before using, yes? So, just, and also I strongly recommend you to use clear all before in the beginning of the script to delete previous variables, because now you have variables in your workspace, and you need to clear your workspace before starting. It's help you to find some errors which you couldn't see. Yes, like here.
Thank you.
So continue working with this. Okay, Abdul Jabbar, what about you?
Okay, I will show you my. I'm from the phone, so I will just share a photo from the laptop.
Okay.
Can you see my screen?
Yes, we can.
Okay. This is for linear regression. This one, this code, and this is for quadric.
I see. Could you run your code?
Yeah, this quadrat. And this for linear regression.
Could you move your camera to the right a little bit? Yes. Okay. It's linear.
Linear, yeah. And this for quadric.
Okay, that's good. Yes, it's correct.
I create a new function for generating coefficients per 0 and per 1. So, and here I have to write the function, the formula from the presentation, yeah?
Yes, that's correct. And after that, in your main script, you need to call this function. Yes.
And this one, you mean?
Here, yes.
One, yeah?
Yes. So here you generate your linear data set, yes? And after that, you calculate coefficients of linear regression. And also the same for quadratic data set. And after that, you need to compare, please, when you finish your function, do this call from the main script and compare your expecting values because you generate your linear data set using some values, yes, of B0 and B1 actually. And after that, you calculate them using expressions, and they should be close to each other. They should be the same actually. If you see that your values are different, so you need to check your function, like you're checking. Yes.
Sorry, can I ask a question? Yeah, from what you're saying, when we calculate our coefficient using our generated function, it should be the same with whatever B0 and B1 we used in our previous function. Is that what you're saying?
They should be close to each other. It's slightly different. For example, you defined B0 as 5.
Yes.
And you predict B0 as 4.8, for example, but it will be close to 5. It should be close to 5.
So basically, we are going to call in our function before we find the coefficient of the function.
Yeah, first we generate.
What I'm saying is that we call in, let's say, xy is equal to linear regress. Then when we call that function, then we use this generated coefficient function to find the coefficients of that particular function, and it should be similar.
They should be similar, yeah.
Okay, thank you.
In the first part of our work, we generate test data sets. It's our experimental data. It's model. And after that, we create a linear model using our data set, and we predict B0 and B1 for our two data sets and analyze the difference between them. Okay, so for today, please finish working on your function. Thank you, Abdul Jabbar. Good job.
Maybe I want to ask one question more. You said compare the coefficients, you mean by finding the coefficient correlation or something else?
You don't need to find correlation coefficient now, only B0 and B1. It's not correlation coefficient. Later, we will calculate R-square metric at close to correlation, but not now.
Okay.
So take formulas from the lecture and repeat it in MATLAB. That's all for today. Okay, thank you. So I think that everyone showed me the screen. Really great to see that you are working on our task and you don't waste your time. So for today, please finish this function to calculate coefficients. Yes, and in the next practice, we will visualize our results and we will try to calculate some metrics like R-square, R-square value, SSE, and also we will plot distribution of our residuals, but it will be our next class. So you have last part of this class for yourself work, okay? Continue working. If you have questions, you may...
I do have a question, actually. Yeah, I just wanted to ask you about the real value and the estimated value of X and Y. Where should we get them?
You don't have estimated value of X. You only have estimated value of Y, because you have a known predictor, yes, and you try to predict your response. Firstly, we define B0 and B1, yes, and using them, we may predict our Y value our predicted value of y, yes, in the base of x. It will be our next step. You just take your estimated coefficients, B0 and B1, yes, predicted B0 and B1 from linear regression model calculation, and predict y with height.
I'm so sorry, I didn't understand.
Okay, you want to understand how to estimate y, yes?
I want to understand how to calculate B0 and B1, since they depend on the values
of x and y, yes.
Yeah, a real x and estimated x, and real y and estimated
real y, yes. Real x and real y. You take your data set and calculate something around this. So you take your real values. In our case, real values means that we are using our modeled data sets.
Yeah, the one like we passed to ABC, or B0 and B1 and N.
We using these coefficients, we create our own data sets, x and y. The next step, we take these values and calculate B0 and B1.
I understand, but here we have only like one value for x and one value for y. We don't have estimated x and real x. We have only x and y.
Yes,
the x and y
enough.
from our data set.
Yes, it's enough. It's okay. It's what we have. It's like an example of experimental data. It's modeled data set.
But in the file, I'm seeing like B1 equals to the sum of the difference between xi and x real and x estimated, multiplied by y real and y estimated.
No, it's not y
it's not estimated. It's mean value.
The mean value.
Yes. It's a line.
Okay.
Mean. Yes.
Yeah.
That means
that's different.
Yes.
Okay.
Yes.
I thought this is the estimated because.
Yeah. Okay.
Okay. Thank you very much.
Thank you. You're welcome. Thank you for your question.
No problem.
Questions?
No.
Okay. So thank you for today. Happy to see all of you here on Zoom. I will upload our record to my YouTube channel. Likes, subscribes, and so see you next week. Next week we have classes, 2 classes as usual, and it begins on 10. We will have classes via Zoom, yes, and we will continue working with our practical task, and it will be our first class. The second class will be about your lab works. So if you have questions about your lab works, if you want to defend your lab work, you may do it in our second class next week. And also we will try to start the second and the third lab work. Unfortunately, we have some problems in synchronization between theory and lab works, because lab works contains some theory that you need to know, and you may find additional information in our classroom, actually, in your materials and in text materials for labs. You will find file lectures. I will share my screen. In our text materials for labs, you will find a lectures PDF file, and here you will see additional theory about some stuff from the lecture. For example, in the first lecture you have some information about normal distribution. In the second, this is visualization, as I remember. The new lab works will be principal component analysis, linear schema analysis. We will talk about it in our lectures and a bit later. Maybe next lecture will be about this. So this PDF file.
It means when we finish the first one, we can start the second one, yeah? The second level.
Yes, of course. You may do it in your own temp, with your own speed. It's okay. So see you next week at 10 in Zoom.
Thank you.
Have a nice day.
Thank you.
Nice day.
Thank you.
Bye.
Goodbye.
Have a nice day.
Bye.
Goodbye.
Bye.